Alexa, turn on the kitchen.
More than 9 billion Wi-Fi devices are in use worldwide, and demands on Wi-Fi networks will keep increasing, with new, ultra-high throughput and low-latency applications proliferating by the day. This is where Wi-Fi 7 comes in. The 7th generation of Wi-Fi technology, Wi-Fi 7, also known as 802.11be, works on all 3 frequency bands. This new standard features extremely high throughput up to 46 gigabits per second, which is 4.8 times faster than Wi-Fi 6 and 13 times faster than Wi-Fi 5. It also includes advances that reduce latency, increase capacity, and boost stability and efficiency. If you're struggling with buffering, lag, or congestion, Wi-Fi 7 will be your solution. Whether you're a smart home enthusiast, a gamer, or a professional, you too can experience the most cutting-edge wireless technology. Building off previous Wi-Fi standards, Wi-Fi 7 introduces 320 MHz ultra-wide bandwidth, 4096 QAM, multi-link operation, multi-RU, preamble puncturing, and 16x16 MU-MIMO to provide massive improvements in speed. Throughput has been doubled, with the maximum bandwidth increased from 160 MHz to 320 MHz. To further enhance peak rates, Wi-Fi 7 adopts a higher order modulation scheme, 4096 QAM. This packs 120% more data for higher speed. The new multi-link operation mode allows aggregation of 2 or more channels from any available frequency band. This enables devices to simultaneously send and receive data across different frequency bands. In addition to further enhancing spectral efficiency, Wi-Fi 7 supports multi-RU management, allowing multiple resource units to be assigned to a single user. Meanwhile, with preamble puncturing, widened portions of bandwidth can be transmitted regardless of interference. Now, every available piece of the spectrum can be used, raising overall network efficiency. Finally, Wi-Fi 7's 16x16 MU-MIMO technology supports 16 streams to transmit data volume to multiple clients at the same time. With all of these, Wi-Fi 7 will serve as the backbone for streaming, voice conferencing, cloud gaming, smart homes, industrial Internet of Things, the metaverse, telemedicine, and more. These exciting enhancements and major lifestyle changes are made possible by Wi-Fi 7's innovative technologies. More scenarios than you could ever imagine will be unlocked. All these breakthroughs will help the digital age to enjoy even more eye-opening experiences. Wi-Fi 7. Wi-Fi like never before.
Now you should disappear.
Dad, I'm ready to watch TV.
Abracadabra, work. Work.
Works.
I can't believe it. You're actually finally good at magic.
The internet's out again.
The kitchen never has Wi-Fi.
Dad, you need to reset the router.
I already did.
Introducing Deco, the solution that transforms your home from a blank canvas into a Wi-Fi masterpiece. Deco is a whole home Wi-Fi system that paints every room in powerful, uninterrupted internet. It's a work of art. Adaptive routing technology automatically finds the fastest path to the internet for every device. Setup is beautifully simple. Just connect via Bluetooth and follow along with the Deco app. Deco has the most comprehensive security of any whole home Wi-Fi system. TP-Link Home Care protects every connected device with antivirus and powerful parental controls. You can even set time limits, filter content, pause the internet. Start with one unit or expand coverage with a few. Deco is a system that grows with you. From non-stop gaming to lag-free streaming and video calls, seamless Wi-Fi is truly a thing of beauty. Deco. Paint your home in Wi-Fi.
Welcome to the point-to-point link installation and configuration guide for TP-Link's outdoor CPEs. In this video, we demonstrate how to build a simple point-to-point link in 3 easy steps, including pre-testing, installation, and alignment. To build the point-to-point link, we need 2 Pharos CPE 510 CPEs and cables that are long enough to connect your outdoor CPE to the indoor PoE adapter. We refer to the 2 CPEs as the AP and the client according to their functions. Each package contains 1 Pharos CPE 510 and a passive PoE adapter, which supplies power to the device via Ethernet cable and acts as a secondary Ethernet port. Pole mounting straps and a power cable are also included. Refer to the installation guide for more detailed information. Prior to installation, we recommend performing basic configurations at home to ensure that the 2 CPEs are able to connect. First, plug the power cable into the adapter's port. Then connect the CPE to the PoE adapter by plugging an Ethernet cable into the PoE port on the adapter and the CPE's LAN 0 port. Next, connect the CPE to a computer via the secondary Ethernet port on the PoE adapter. To begin the configuration, change the IP address of the computer. To do this, open the Network and Sharing Center on your PC, click the Ethernet button, and select Properties. Double-click the IPv4 line and change the IP address to 192.168.0.10. Then, set the subnet mask to match the information currently displayed on the screen. Then, open your browser and enter 192.168.0.254 in the address bar. Log in using the default username and password, which are both admin. Then choose the appropriate region or country. Here, we use test mode for the purpose of this example. At this point, you can change the password to enhance the security of your device. Now click Quick Setup and choose AP mode. You can change the management IP address or continue using the default address. Here we change the SSID of this device to CPE510_P2P for easy recognition. The quick setup is now complete, and you will be taken to the status page. The basic information for the CPE will appear on the left. The information for the connected device and its wireless settings will appear on the right, and the throughput monitor will appear on the bottom. After configuring the first CPE 510 in AP mode, we can configure the other one in client mode. The hardware connections, web UI, IP address, username, password, and region are all the same as they were for the first CPE 510. Once you have completed the configuration, you can change the original password. Then select the Quick Setup option and choose Client Mode. Change the IP address to one that is different from that of the AP, such as 192.168.0.253, and then find the wireless signal from the AP by clicking the Survey button. Connect to the network provided by the CPE 510, which is identified as CPE 510_P2P. After the changes have taken effect, the basic configuration will be complete. Since we have changed the management IP address of the client CPE, this page will bring us to the new address where we can check the radio status and ensure that the CPE has successfully connected to the AP. The next step is to choose a good set of installation locations. There should be a clear line of sight between the two locations, and both should provide convenient options for connecting the necessary cables. We recommend the use of shielded cables for installation in outdoor environments, which will provide excellent lightning protection. When affixing the device, it is recommended that you use Google Maps to determine the approximate direction that the two CPEs should be facing to form a connection. Install the client following the same steps to determine the best approximate orientation. After installing the CPEs, try to connect the two devices. From the AP side, you should perform a spectrum analysis to find the most suitable channel. To do this, choose the Spectrum Analysis tool in the toolbar, select the 5730 to 5850 frequency range, which corresponds with band 4, and then click Start. This allows us to see the signal strength and environmental noise for each frequency in real time. It is normal for the signal strength to experience small fluctuations from moment to moment. You should notice that some channels are subject to less interference than others. When you are confident that you have found the most stable frequency, you can select the Wireless tab and change the channel to this frequency. You should also input a distance value that is as accurate as possible. You can also choose Auto, which estimates the distance between the two devices automatically. Then click the Apply button and remember to save the changes. Now you should confirm that the selected channel works by pinging the client from the AP side. To do this, open the command window and ping the client using its IP address, which is 192.168.0.253. It may take up to 1 minute for the client to successfully connect to the AP. Then check the status of the AP in the configuration page. In the Monitor section, you will be able to view connected devices in the Stations section. Since the original positioning was determined using simple data from Google Maps, you will now need to perform a more precise alignment. Begin by securing the client, then shift the AP from side to side. You can monitor the signal strength on the screen, which is subject to a 1 to 2 second delay. The position with the highest signal strength indicates the ideal orientation for the device. Once this process has been completed for the AP, you should follow the same procedure for the client to ensure the best possible wireless performance. Once you have successfully completed these steps, a simple point-to-point link is established. This link can be used to share an internet connection from point A to point B, or to remotely monitor events taking place at point B from point A by installing a camera.
Hi there, please leave the item by the door.
Leave the item by the door.
Hi Alexa, turn on the plug.
Bye.